All right, so we're going to finish up this example 3 with some triads. So remember, for triads, you're going to pause and you're going to do it by yourself. So the first triad is 2. Are these perfect squares? Are they perfect squares? Okay. So take a minute, pause this, and decide whether or not they're perfect squares. All right, you should have paused and you should be back by now. 2 is not a perfect square. And that's because 1 squared is 1, and 2 squared is 4. So since 2 is in between 1 and 4, I know that it's not a perfect square. Okay, how about 36? 36 is a perfect square. Yes, it's a perfect square because 6 squared is 36. So we know it's a perfect square. All right, so now we're going to start on example 4. Okay, so example 4 has to do with the world outside of the classroom. Sometimes teachers use the term real world, but I'm going to use the term outside the classroom. So the reason why it's called a square, or it's called squared, so square numbers, is because if you draw a square, what do you know about the side lengths of a square? The side lengths of a square are going to be equal. So if this side length over here is 5, then the bottom side length is also going to be 5. So if I've got 5 by 5, okay? So a square, the area of a square is the length times width. So it's 5 times 5, which is the same as 5 squared, which is why it's called a square number, because the area is represented with an exponent of 2, or as a square number. Okay, so outside the classroom, we're going to think about other things that we see around the outside the classroom that are squared also. Okay, so let's talk about, so you know that sometimes at parks they have like life-size chessboards? I'm going to write this problem. All right, so the problem is a life-size chessboard has a side length of 11 yards. What is the area? So maybe you know this, maybe you don't, but a chessboard is a square. Okay? So again, we're using the idea of a perfect square. So if one of the sides is 11 yards and it's a square, what does this other side have to be? It has to be 11 yards also, which means it's asking us, what is 11 squared? So we're going to do 11 squared. If you don't know that off the top of your head, then we're just going to do the multiplication down here. If you do because you remember it from yesterday's work, that's awesome. So go ahead and write it down. 1 times 1 is 1. 1 times 1 is 1. Placeholder 0 because I'm into the tens place. 1 times 1 is 1. 1 times 1 is 1. So I get 121. 11 squared is 121. And since they use yards, I know that this is yards to the second power. So that's the area of a life-size chessboard. Okay, I'm going to give you a triad for this. All right, so the triad is a 4-square court contains 4 identical squares. Use the diagram to find the area. So as you've all probably seen a 4-square court, you know that it kind of looks like this, and it's got numbers inside so that you know which position is first position and which position is last position. So what we're going to do is we need to find, it says use the diagram to find the area. Notice in the diagram, it tells me that one of the squares is 6 feet long. Okay, so take a minute, pause this video, try it on your own, and then come back and we'll work through it. All right, by now you should be back. You should have tried it on your own. So this one square is 6 feet tall from here to here. If they're identical squares, which it says that they are, then this one is also 6 feet tall, which means these are 6 feet tall each also, 6 feet and 6 feet. Okay. Now, if each of those sides is 6 feet, then we have a 12-foot, altogether, a 12-foot by 12-foot. Okay, which means we have 12 squared, which is 144 feet squared.